I'm tackling a problem using Sklearn's Gaussian process regression with a radial basis function, RBF, kernel. The RBF kernel uses a parameter called gamma, that affects how the model behaves. I'm seeing overfitting, which means my model is too closely tied to my training data and isn't generalizing well to new data. I need to figure out how to adjust gamma to improve the model. My approach involves understanding how the gamma parameter in the RBF kernel impacts model complexity and, thus, overfitting versus underfitting. I will carefully analyze how changes in gamma affect the model's ability to generalize to new data. Gamma controls the length scale of the kernel. A larger gamma means a shorter length scale, making the model sensitive to small changes in the data. Think of it like a magnifying glass. It zooms in on tiny details, which is great for capturing detail but can lead to memorizing noise. Conversely, a smaller gamma results in a larger length scale, which means my model considers data points from a broader region, leading to a simpler, smoother model that's less sensitive to minor fluctuations. I need to find a balance. I have determined that decreasing gamma will reduce overfitting and that adding a noise term to the kernel is another good way to improve the model. Decreasing gamma makes the model smoother and less focused on the noise in my training data. Option B. Lowering gamma reduces the model's complexity, decreasing overfitting. Think of it like stepping back from the details and seeing the bigger picture. Option C. Adding noise introduces uncertainty to the model, preventing it from becoming overly confident in its predictions and reducing overfitting. It's like adding a little bit of doubt to make the model less certain and therefore more robust. Therefore, options B and C are correct. I'm dealing with a Gaussian process regression model using a radial basis function, RBF, kernel. The RBF kernel measures similarity between data points using a formula based on the distance between them and a hyperparameter, gamma. My current model is overfitting, meaning it's too closely matching my training data and won't generalize well to new data. Increasing gamma makes the RBF kernel more sensitive to small changes in data point distances. This means the model will fit the training data even more tightly, which worsens overfitting. I don't want to do this. Decreasing gamma makes the RBF kernel less sensitive to small distance changes. The model becomes smoother and less prone to overfitting. It generalizes better to unseen data. I should try this. Adding a noise term regularizes the model. It prevents the model from being too confident in its predictions and thus reduces overfitting. Think of it as adding a little uncertainty to the model's calculations, which helps it avoid getting overly specific to the training data. I should consider this too. Decreasing the length scale is the same as increasing gamma. This would make the model even more complex and lead to more overfitting. I definitely don't want to do that. I'm using a Gaussian process regression model with a radial basis function, RBF, kernel. The RBF kernel uses a fancy equation to measure how similar two data points are. That equation uses a hyperparameter called gamma. Currently, my model is overfitting. It's too focused on the training data and doesn't generalize well to new data. That's a problem. If I increase gamma, I make the model more sensitive to small differences between data points. This increases the complexity and will probably make the overfitting worse. Not a good idea. If I decrease gamma, it'll make the model less sensitive to small differences, resulting in smoother predictions. This will simplify the model and probably reduce overfitting. Sounds much better. This is my top choice. Adding noise makes the model less confident in its own predictions. It basically adds a bit of uncertainty, preventing the model from being too sure about the training data. It's a regularization technique that helps prevent overfitting. A solid choice as well. Decreasing the length scale is like increasing gamma. It will make the model more complex and prone to overfitting. I'll avoid this one. I'm dealing with a Gaussian process regression model that uses a radial basis function, RBF, kernel. The RBF kernel uses a mathematical function to measure the similarity between data points. The current model is overfitting, meaning it's too closely tied to the training data and won't generalize well to new data. I need to fix this overfitting. My Gaussian process regression model is overfitting, meaning it performs well on the training data but poorly on unseen data. This is because it has learned the training data too well, including noise. I need to adjust my model to improve its generalization performance. I can reduce the value of gamma. Remember, gamma controls the length scale in the RBF kernel. A smaller gamma means a larger length scale, leading to a simpler, smoother model that's less likely to overfit. This is a good option. I can add a noise term to the kernel. This is a regularization technique. Adding a small amount of noise forces the model to be less confident in its predictions and prevents it from overfitting to the training data. This is another great option. I should avoid decreasing the length scale. This is the same as increasing gamma, which will make the model even more complex and worsen the overfitting problem. That would make things worse. I should avoid increasing gamma. Increasing gamma will decrease the length scale, resulting in a more complex model that will likely overfit even more. That's definitely not what I want. I see overfitting, which means the model is too confident in its predictions. Adding a small amount of noise to the kernel matrix will introduce uncertainty and make the model's predictions more realistic and less prone to overfitting. Think of it like adding a bit of salt to a dish. It enhances the overall flavor without overpowering it. It's a regularization technique. It's a great way to prevent overconfidence. Increasing gamma makes the kernel function more sensitive to small changes in the input data. This means the model will fit the training data more closely, but this will likely lead to overfitting because it will model noise too closely. It's like trying to draw a line through every single data point, instead of finding the general trend. Decreasing gamma has the opposite effect. The model becomes smoother and less sensitive to individual data points, and therefore less prone to overfitting. It's like drawing a smoother line that captures the overall trend better, ignoring small fluctuations. This is a good approach for reducing overfitting. Decreasing the length scale is the same as increasing gamma. Both actions result in a more complex model that is more likely to overfit. It would worsen the overfitting that you're trying to fix. We're using a Gaussian process regression model with a radial basis function, RBF, kernel. Think of it as a fancy way to predict values, using a kernel to measure the similarity between data points. The RBF kernel uses a hyperparameter gamma to control how quickly the similarity decays with distance. The problem is our model is overfitting the training data and not generalizing well to new data. Let's fix that. I suggest we decrease gamma. Remember, gamma is related to how localized each data point's influence is. A smaller gamma means a larger length scale, allowing each data point to influence the prediction in a wider area. This makes the model simpler and less prone to overfitting. Think of it like smoothing out wrinkles in the model. Adding a noise term is another excellent idea. This injects uncertainty into the model's predictions, preventing it from being too confident in fitting the noisy parts of the training data. It's like adding a little bit of randomness, helping the model avoid being too precise and focusing instead on the big picture. This makes the model more robust to noisy data and less prone to overfitting. Let's see how this improves our model's accuracy. Increasing gamma is not the right choice. This would make the model more complex, fitting the data even closer, making it even more likely to overfit. This will make things worse. Decreasing the length scale is exactly the same as increasing gamma. We've already talked about the problem with increasing gamma. This also increases model complexity. We need to avoid this. I'm dealing with a Gaussian process regression model that uses the radial basis function, RBF, kernel. The RBF kernel measures similarity between data points using a formula involving a hyperparameter called gamma. Right now, my model is overfitting. It's performing great on the training data but poorly on new, unseen data. I need to fix this. The core issue is overfitting in my Gaussian process regression model that uses the RBF kernel. The RBF kernel's formula is k x equals express gamma asterisk xx squared. This measures the similarity between data points x and x using their Euclidean distance and gamma. The problem: I want to reduce overfitting. I'm looking for a way to adjust the gamma hyperparameter within the RBF kernel to improve the model's ability to generalize to new data by reducing overfitting. This question directly focuses on the impact of gamma on the model's performance. Increasing gamma makes the model more sensitive to small changes in the data, potentially worsening overfitting because it creates a more complex model. I can see that would make things worse. Decreasing gamma smooths the model's response to changes in data, potentially improving generalization and reducing overfitting. This will likely help, making the model less sensitive to the noise in the training data. Adding a noise term to the kernel is a regularization technique. It injects uncertainty into the model's predictions, preventing it from becoming too confident in its fit to the training data and thus reducing overfitting. This is a good strategy. Decreasing the length scale is the same as increasing gamma, which leads to overfitting, just like option A. This also will make things worse.